we will discuss about program number 25. Program statement says, write a program in Java to accept a number and check whether the number is perfect number or not. So I have given here name of the class as perfect number as per the program statement, and within the main method as per the program statement I have passed here one argument of integer type, and name of the variable is number that will store the number entered by the user, and we will check whether that number that will be perfect number or not, that is stored in the variable number. Now first of all we have to understand what is perfect number. To understand perfect number, the definition of perfect number, I will quote here one example. For example, 6 is a perfect number. Factor of 6 are 1, 2, 3 and 6. These are the factors of number 6. So perfect number definition says that if we find out the factors of any number, like here we have an example of number 6 and these are the factors of number 6. After finding out the factor, we have to exclude the number itself from the factors and we have to sum up the remaining factors of the number. So these are the remaining factors. We have to exclude the number itself from the factors because each number is the factor of itself. So we will exclude the number and we will sum up the remaining factors. If we sum up 1 plus 2 plus 3, that makes 6, and the sum of the remaining factors is equivalent to the original number. This is the reason the 6 is called perfect number. So definition becomes, a number is said to be perfect number if sum of its factor excluding the number itself is equivalent to the original number. That is known as perfect number. So our first requirement is to find out the factors. A number is said to be a factor of another number if it is divisible by that number. Like here 2 is the factor of 6. Why? Because 2 divides 6 completely. What does it mean? If we divide 6 by 2, it leaves the remainder 0. If remainder is 0, we will say 6 is divisible by 2. If it leaves the remainder, we will say it is not divisible completely. So we have to check whether the remainder is 0 or not. So as we had studied while covering up the theoretical portion, in Java programming language we have one operator using which we can result in remainder. We can find out the remainder, and that operator is known as modulus operator. This is the modulus operator. Using this operator we can find out the remainder. This operator results in remainder. If I divide, this operator is used for dividing two numbers, but it returns, it results in what type of value? It results in remainder. So 6 divided by 2, we are dividing it by using modulus operator, so remainder will be 0 in this case. Remainder will be 0. So this means 2 is the factor of 6. So this logic we have to use. So what is the general process we follow for finding out the remainder? First, we divide the given number by 1, then 2, then 3, then 4, then 5, then 6, and whatever the number that divides the original number completely, leaving remainder 0, we call those numbers as factors. So first step is how to find out the factors using Java programming language, or we can say first step is to create the programming logic for finding out the factors. So what will be the logic? If number is now definitely user will enter the number in this, whatever the number user will enter, that will be stored in the variable number. Let us suppose user enter 6. So number stored in this variable is 6. Then we have to check, we have to divide it by using modulus operator, because modulus operator results in remainder, and we have to check whether remainder is equal to 0 or not. So first we have to divide it by 1, then by 2, then 3, then 4, then 5, then 6 number itself. So this process we have to follow. So how we can change the numbers? By using a variable. We can assign first value to I 1, then 2, then 3, then 4, then 5, then 6. So, and we have to check here equality, whether this will result in 0 or not. If it results in 0, we will say it's a factor. That if this condition is true, we will say whatever number that divides, that is stored in the I, if it divides the number that is stored in the number variable completely, and if it leaves the remainder 0, we will say here will be what? 0 will be returned. 0 is equivalent to 0. Only in that case this relational operator will result in true. So if you so how we will check? If let us suppose 6 is the number, so first we will check, we will divide 6 by 1. 6 mod 1, definitely this will result in 0. So here will be what? 0 is equal to 0, and this relational operator will result in true. And what now we can print the value of I. If this condition is true, I stores 1, so 1 is the factor. Or we can sum up, that is our requirement. Or we can display it by using system.outprint I, since I stores 1 at presently. Now if I change the value of this, let us suppose now I stores 2, number is same 6. Now whether we have to check here whether 2 is the factor of 6 or not. So again this modulus operator will result in remainder 2 divided by 6, remainder will be 0. 0 is equal to 0. This means again this relational operator, that is double equal to, will result in true value. So if condition is true, whatever is the statement within the body, if it is print statement, then we can print the value of I, that is 2 is the factor. Or if we want to add, we can sum up. We will discuss how to sum up the factors. Similarly, if I change the value, let us suppose value of I here is 3. So now it becomes 3 mod 6 mod 3. So it will result again, this modulus operator will result in remainder, that is 0. So 0 is equivalent to 0, that is true. So if it is 4, at that point what will happen? This test condition, this will result in remainder 2 will be the remainder. If we divide 6 by 4, remainder will be 2, and 2 is equal to 0. This is false, so 4 is not factor of 6. So this means we are quite close to creating the logic of finding out the factors. So you can see what I'm doing here. I'm changing the value. Next time the fact if I change the value to 5, value of I to 5, so it will be here 6 mod 5. This 6 is divided by 5, remainder will be 1, since this modulus operator results in remainder. So 1 is equal to 0. Again this relational operator will result in false. Why? Because 1 is not equal to 0. And this means 5 is not the factor of 6. We know that. So next time we will increase the value by 6. Number itself is a factor, every number that we know. So this means what we have observed here, if you you have observed here that value here of I is changed. We have to change the value. First it will be 1, then 2, then 3, and how we can do that? By using loop. So we will use here one loop for I'm going to declare this int variable here for the time being. Int I, that is control variable, and value will be I, and our loop will run till this number, okay, okay, till this variable. And since we have to exclude, so I am not going to use here equal to sign. If we place here equal to sign after less than, then our number will be included, but okay, original number will be included in the factor. So I want to exclude, so I will omit this equal to sign, and for the first time value of I will be 1, next time it will be 2, then 3. Okay, we have to check all the numbers whether which number is the factor. User can enter any number, and then within the body this logic will be there, because we have to repeat this of process of checking again and again. Okay, so this will be there, and okay, so now the value of I will keep on changing. This loop is changing the value here, okay, which we have discussed, 1, 2, 3, 4. Okay, and why we have used here less than instead of using less than equal to? Okay, if we use here less than equal to, okay, then original number will be included, then value of here I will be what, 6. Let us suppose user enter 6, so here will be what, 6 mod 6, but we don't want that, because we want to exclude number itself from the factor. So this is the reason we will omit this equal to sign from the test condition. Now, okay, now either we can print it, okay, if I let me show you, if I print it all the factors, if I want this okay, as per program requirement it is not asked that we have to print the factors, but let me show you that whether it displays the factors or not. Okay, I'm going to print the I, because we are checking here whether I is the factor of this number or not, whatever the value I will store. First value of I will be 1, then 2, 3, 4, 5, 6 till that number. Okay, value of number, whatever the value number will store, that will be fixed. So now let me use a pair of curly bracket. Okay, it's good practice for the beginners, and we have studied if there is a single statement, then we can omit the pair of curly braces. So I'm going to make this comment, and if I run this program, okay, and let me use here ln, so that factors will be printed in a line, okay, in a column, okay, rather than in a row. So I will run this program, and I will enter here number 6. Okay, so 6 will get stored in this variable number, and if I click on OK, so we can see the factors excluding the number itself, that is 6. So we have printed the factors, but our program requirement is not to print the factors. Our program requirement is to sum up. Okay, what is perfect number? The definition of perfect number says that we have to sum up the factors excluding the number, original number itself. Okay, the remaining factors. So we have to sum up 1 plus 2 plus 3. So what we can do, we can declare here one variable for summing up. Sum is equal to 0. Let us initialize one variable sum of integer type. Okay, and instead of using this statement here, we can use here sum is equal to sum plus I, because value of I is first time it will be 1, then it will be 2 and 3, because these are the three numbers which are factor, which we have displayed. So now they will be added. First it will be 0 plus 1, then sum will store 1. Okay, next time this condition will be true for this value 2. Here will be 1 plus 2, that will make 3. Next time the sum will store 3. So here will be 3 plus, okay, next time the value of I will be 3. Okay, because 3 is the factor. This test condition will become true when value of I will be 3. So 3 plus 3, that will make 6. Now sum will store what? 6 in the end. Okay, so we have summed up the digits, okay, not digits, sorry, the factors of the numbers 6, that is 1, 2, 3, excluding the number itself. Now in the end, after the termination of loop, we have to display the value of sum. Okay, if we want to check, we can check here. Okay, this is not our program requirement to display. We have to check, okay, that number is perfect or not. Okay, I want to show you here that whether what value sum stores. If I display the value, okay, if I try to display the variable value, okay, name of the variable is sum. Okay, so whatever the value sum stores, that will be displayed. So if I run this, so I'm going to enter here same number 6, and factors of 6 are 1, 2, 3 that we have seen. 1 plus 2 plus 3, that is what? 6. So we can see here 6. So we have summed up the factors, okay, of number 6 excluding the original number, okay, that is 6. Now only we have, okay, this is not our requirement. What is our requirement? We have to check whether the original number, okay, that is number that is stored in this variable, that is equivalent to sum or not. If it is equal, we will say it is a perfect number. So here we will use condition after the loop. If the value stored in sum is equal to original number, okay, then we will say, okay, we can use a pair of brackets to define the body of if, and we will say here system dot out dot print, okay, print perfect number, and if this condition is false, if let us suppose it doesn't match, okay, if this condition, this relational operator results in false value, in what scenario it will result false? If value stored in some variable is different from the number entered by the user in the number variable, okay, so then else will execute, okay, and in case of else, what we want to print, that number is not, okay, number not a perfect number. So I will copy this and I will paste it here, and here only I have to change this, not a perfect number. Now let us run this program, okay, our program is complete. If I enter 6, okay, then it will display perfect number, okay, that we have, okay. If I enter here another number 12, not a perfect number, okay, so our program is working fine, okay. So this completes the explanation of this program, that is program number 25.